In this video I'll show you how to use SmartGeo as a graphical user interface of HydroGEN. HydroGEN is a random field generator developed by Professor Alberto Bellin from the University of Trento. With this program is possible to obtain maps of parameters, heterogeneous maps which are spatially correlated, so which are characterized by a mean, a variance, and a covariance function, which can be of different types. For instance, with an exponential isotropic covariance function, we obtain an heterogeneous field like this. With an anisotropic exponential covariance function, we obtain a field like this. With a Gaussian, a field like this, self-similar. So by using different covariance function, we can obtain a different pattern of the heterogeneity for representing our aquifer and the hydraulic properties of our aquifer. In the SmartGeo info menu, we can select on the tutorials, and here we have the list of all the 5 tutorials available. So by clicking on HydroGEN, we can follow all the steps here from this tutorial. So we can now open a previously done tutorials called tutorial first. So by clicking on the domain button here, we can edit the properties correspondent to the domain layer. And we can see that we have one polygon which defines our domain, and a small polygon which represents a hole inside our domain. We need to define a grid because HydroGEN generates an attribute for each cell of the grid, so we have to represent our domain by discretizing it through a regular grid. It is possible also to draw direct measurements of the attribute that you want to reproduce. Okay, so now we need to save the project. And this is all. So for running in HydroGEN simulations, only for obtaining a map like this, we only need to define the domain, the grid, and eventually the direct measurements. But if we don't have direct measurement, it's not a problem at all. So we click on the Run button. So as you can see, the simulation times is empty because we are not running flow simulations. And here we need to define the mean, the variance, and the covariance function of our field. In particular, the mean of k, which is the attribute, is given in the logarithm form in order to avoid negative values. So in this case, here in this column, we need to type the value of the mean that we want to set for our field. The variance is the variance of the logarithm transformation of k, which is the attribute. In this case, we set it equal to 0.8. And then we need to set the integral case along the x and y direction. We don't need to define these two values because they are necessary only for running flow simulations, so for reproducing the aquifer behavior. We don't need to fill these parameters, but here we need to define all these parameters which are necessary for HydroGEN. Okay, we can define the number of simulations that we want to obtain. Since HydroGEN generates stochastic fields, it is able to generate multiple fields characterized by the same mean, the same variance, and the same covariance function. In this case, we can we can define 10 Monte Carlo simulations. The seed number is a random number, and here we need to select the shape of the covariance function, so exponential and Gaussian. The multiple parameters are not necessary because we are running only hydrogen. So we need to save the settings in order to be able to run again the same simulations with the same parameters. And it's better to store the setting files into the same directory where we saved the project. So in this case is the tutorial first directory, and we save the settings in these files. Okay, after this we can run SmartGeo by clicking on the Run button. We stop the simulation, and now we can load the results by clicking on the Results button, placing the directory in the right folder, so tutorial first, and as you can see here you can load all the 10 Monte Carlo simulations generated, but also an average field of all the Monte Carlos. So in this case we decided to load the first Monte Carlo. Here we can select the parameters to visualize. In this case this is the attribute simulated. This is its logarithm transformation, and these parameters at the moment are constant and they are not useful for now. So we decided to select and visualize the logarithm transformation of the hydraulic conductivity. So this is the range and this is the color scale. In correspondence of the direct measurements, we have exactly the value assigned to the direct measurement. But from one direct measurement to another direct measurement, the field is randomly generated according to the shape of the covariance function assigned. We can visualize the name of the direct measurements. For instance, if we right click on the layer, we select create label layer, so here we can visualize the name of the direct measurements. If you want to export the grid generated, we need to right click on the name of the file and select export to 2D scatter, and so we type the name. In the right folder we can find the exported grid in a scatter form, so in two-dimensional scatter form, the x, the y, and the value. The null value is equal to minus 999. Thank you for your attention. Bye.